It's in continuation. Let's see. That is ammeter, right? On electricity lecture 6. So ammeter is used to measure current. Used to measure current, right? And it is always connected in series, right? Right. Always connected in series. Always connected in series. Students, we want to measure the current. So resistance opposes the flow of current or not, Semi? Resistance that opposes the flow of current or not? Opposes, na? Yes or no? Are you listening?
Yes.
So if I want to measure the current, so I want the maximum current should flow through the ammeter or not? How much current is flowing in the circuit? That should flow through the ammeter, correct? Yes.
Yes.
So that means the internal resistance of the ammeter should be low or high?
Low.
Low. So right, internal resistance of ammeter. Internal resistance of ammeter should be low. Should be low. Understood this thing, students? Understood or not?
Yes,
Yes.
sir.
Just another one thing, very small thing I'm saying over you over here, right? Just see here, students. Let for a practical case, let's take. Let this is 10 ohm resistance. How much ohm resistance, students?
10.
10 ohm. And here one ammeter is connected. And here there is a voltage. And the voltage is 20 volts. So you think how much current will flow through this ammeter? V is equal to IR. I is equal to how much? V by R. That is 20 by 10. How much?
2 ampere.
So 2 ampere current will flow. Yes or no, students?
Yes, sir.
Yes.
And the ammeter, suddenly what I did, I made this resistance to be 20 ohm. Sorry, let the resistance to be 5 ohm. How much, students? 5 ohm. And the same voltage, that is 20 volt, correct? So say me how much current will flow here?
4 ampere.
4.
That means the current is increased, na?
Yes, sir.
But I am saying that the ammeter is capable of reading maximum 2 ampere. Maximum 2 ampere.
2 ampere.
So can we connect the same ammeter in the second case? Do you think?
No, sir.
2 ampere, na? We cannot do that, right?
No, sir.
What is to be done in this case? Because but I am having that ammeter. I want to measure. I want to use that one. So what can be done? So somehow we have to divide the current, right? Somehow we have to divide the current. Getting my point, na, students?
Yes, sir.
So how to divide the current? I could do two things, right? Either I could connect like something like 5 ohm here and 5 ohm here. The same circuit will be again for again 2 ampere current will flow, right? Yes or no? Well, connect a 5 ohm resistance externally, then the same thing will happen or not? Getting my point, na? Are you getting it?
Yes.
But another one thing I just wanted to do, what I did, the same ammeter I used the same ammeter, but it was 5 ohm. I connected another 5 ohm like this, right? So now what will happen to the circuit? Just I'm saying the analysis, right? You will get questions on that. So what will happen? Just understand. What will happen here, students? I connected one 5 ohm in series, then it will 2 ampere current will flow. The 4 ampere will not be there, right or not? Getting the students? But if I'll connect a resistance in parallel, what will happen? The net resistance is going to be how much? 2.5 ohm, na?
Yes, sir.
That means the current is going to increase over here. It will not be 2 ampere, correct?
Yes, sir.
Actually, four diagrams will be there. Four diagrams will be there, right? And in every diagram, you may check whether the circuit is correct or not. Which ammeter to be used, you can select, right? By taking the total resistance and by taking the total voltage. Yes or no?
Yes, sir.
Yes, sir.
Sir.
Understood this part about ammeter? You all understood?
Yes, sir.
Then what is voltmeter, student? You will get questions on ammeter. What is voltmeter?
So the device of measuring voltage.
Voltmeter, right? How the voltmeter is connected, students? They want to measure the voltage, right? This is 10 ohm. This is 5 ohm, right? There is a voltage 30 volt, right? So what is the total current will be here, student? 30 by 15, 2 ampere, na? Yes or no?
Yes, sir.
And if I want to take how much voltage will be dropped here, then I have to connect a voltmeter parallelly, right? Yes or no?
Yes.
Measures voltage. Voltmeter measures voltage. And always connected in parallel.
So why parallel?
Say, students, see what remains same in parallel? Voltage, na? Yes or no? Voltage.
Yes, sir.
And you know V is equal to IR. Yes or no?
Yes.
So I want to measure the maximum voltage. I want to measure the maximum voltage. So the resistance should be maximum, na? Whatever the total voltage going through it, I want to measure that, right? So V is
Yes, sir.
equal to IR, correct?
Yes.
If V is equal to IR, then we can write here maximum voltage to drop there. So same internal resistance of voltmeter should be less or high?
High.
High.
Why? Because maximum resistance will be there, so that maximum drop will be there. Na? If resistance will be low, then the whole voltage will not drop to the across the voltmeter, right? Where resistance is more, that drop is more, na? Understood, students?
Yes, sir.
Yes, sir.
Internal resistance of voltmeter is more. Understood this one?
Yes, sir.
Got a little bit idea about series voltage and ammeter. Students got, na?
Yes, sir.
Yes, sir.
Power, electrical energy and power. Right, electrical energy and power. Electrical power, right? So electrical power means what, students? Students, power is equal to W by T, na? Yes or no? And
Yes, sir.
W is equal to W by Q, you know? So W is equal to VQ, right? So you can write
Yes.
as VQ. And VQ by T, Q by T is I, na? So power is equal to voltage into current, yes or no? Understood?
Yes.
Yes, sir.
So P is equal to also, if you know Ohm's law, V is equal to IR, right? And then that can be written as I square R, na, students? Okay, nahi? Yes or no, students?
Yes, sir.
And VI, and in place of I, you can also put V by R. So that can also be written as V square by R, correct? Yes or no?
Yes.
Yes, sir.
Students, there is a bulb. See, there is a bulb rated 110 volt, right? 100 watt. What does it mean, students? What does it mean? 110 volt, 100 watt. What does it mean? That means, student, this is the rating of the bulb, right? If you are giving 110 volt, it will consume how much power? 100 watt. But if to the same voltage I will be giving 50 volt, then you think how much power will it be consuming?
Less power.
Less means how much? We want to calculate, right?
Yes.
So from the rating only, from the rating of the bulb only, from the rating of the bulb, see, P is given how much? 100 watt. V is given 110 volt, right? Yes or no? And P is equal to V square by R.
Yes, sir.
P is equal to V square by R. So you can calculate resistance of the ball, that is V square by P, correct?
Yes,
That is
sir.
110 into 110 by 100. You can write or not? So that is 121, correct? Ohm. All got, na?
Yes, sir.
Yes, sir.
Student, once the ball is designed, then its internal resistance is going to be constant. That cannot be changed. Yes or no? This is the rating. So from the rating only you can determine the resistance. And in the second case, I am saying to the same bulb, I am giving how much voltage? 50 volt I am giving. How much giving? 50 volt, correct? So power will be how much?
Yes, sir.
V is equal to V square by R. And you know V is how much now? 50 into 50 divided by R is how much? 121. Getting the students? Getting or not all?
Yes, sir.
So somehow you can calculate this one.
20.6.
Yes,
Students all understood how to calculate? If the rated voltage is changing, how to calculate? You can calculate that one?
yes, sir.
Yes or no?
Yes, sir.
Understood now?
Sir, we'll only consider the internal resistance of the bulb.
Yes, internal resistance you calculate. Then you put how much input voltage. Then again you put V square by R, right? Because if I'm giving 110 volt, normally students make a mistake. What, sir? 110 volt, 100 watt, 50 watt, 55 volt giving. Then sir, it will be something 50 watt. No, it's not like that. It will not vary like that. Getting my point now?
Sir, if the circuit has some resistor,
Then that will be considered. That is separate thing. That is separate thing. How much will be the current flowing? But for the bulb, I am saying only, right?
yes.
Which bulb consumes more power? It will glow more, right?
Yes. Sir.
That means in the question, let I am giving an example. There is a bulb. This was 100 volt I was giving. Now what I did, I connected two bulbs, right? What will happen here, Semi? Same bulb. So now the current will divide, right? And the voltage will also divide. But resistance is same. So parameters are going to change or not? Getting my point, students?
Yes, sir.
Next, student, let's see parallel combination, right? Let's see power in parallel combination. Power in parallel combination. Power in parallel combination. So 1 by Rp is equal to how much, student? 1 by R1 plus 1 by R2 plus 1 by R3, right? Yes or no? Let's see here. So this is resistance in parallel, and power parallel is equal to how much? V square by resistance in parallel, right? Yes or no? And that is equal to V square by Rp. V square means Rp means how much, students? V square by R1, right? 1 by Rp means how much? V square by R1, V square by R2 plus V square by R3, right?
Yes, sir.
Individual power P1 plus P2 plus P3. If three bulbs are connected in parallel, then what you will do? Individual power is given. Then you can calculate the total power, right? That is P1 plus P2 plus P3. You can calculate the total power. Yes or no?
Yes, sir.
Yes. Sir.
So there no need to think anything, just you add the three powers, then you will get the combined power, right?
Yes, sir.
Yes or no? Then let's go power consumption in series combination. Right? Power consumption in series combination. Power consumption in series combination, right? Student, in series what happens? Rs is equal to R1 plus R2 plus R3, na? And power in series is equal to how much? V square by Rs, correct? So we can write here V square by R1 plus R2 plus R3. Can we write or not?
Yes, sir.
So here little modification I am making. Let's make V square was there, right? I did what? I divided V square, right? That means I you know, P1 is equal to how much? V square by R1, na? P2 is equal to how much? V square by R2, na?
Yes, sir.
P3 is equal to how much? V square by R.
By R3.
So from there, R1 is equal to how much? V square by P, na? So in case of R1, I can put V square by P. 1. Yes. Then V square by P2. Then V square by P3, correct?
Yes, sir.
Got or not? So by solving
Yes, sir.
this one, you will see 1 by PS is equal to how much? 1 by P1 plus 1 by P2 plus 1 by P3, right? Yes or no? Just,
Yes,
just throw away the misconception in the mind. If three bulbs are connected in series, then the power will be added. No, they'll be treated like parallel, right? Yes or no? Let I'm saying you there is a bulb here P, another bulb is connected here P. They're connected in parallel. What is the equivalent power? So simply like resistance, you will power. Say here what will be power 2P, right? But if two bulbs are connected in parallel, right, series, so what will the equivalent power here? P by 2. Understood, na, students?
Yes, sir.
All understood this one, students?
yes, sir.
Yes, sir.
And there is something energy calculation in case of bulb, right? There is a consideration, energy calculation. एनर्जी कैलकुलेशन. घर में जो इलेक्ट्रिक है किससे इलेक्ट्रिक कैलकुलेट करते हैं? स्टूडेंट्स देखो, इलेक्ट्रिक एनर्जी का एक यूनिट होता है 1 किलोवाट आवर. बोलते हैं ना घर में 200 यूनिट आया, सो 1 यूनिट मींस हाउ मच? 1 किलोवाट आवर. गेटिंग द स्टूडेंट्स ऑल?
Yes,
1 unit means 1 kilowatt hour. 1 kilowatt hour. Understood, students?
yes, sir. Yes,
1 kilowatt means how much watt? 10 to the power 3 watt, right? 1 hour means how much second? 3600 second, correct? Yes or no, students?
yes, sir.
Yes.
And there is a particular case. Let's for per unit cost. Per unit cost will be given in the question, right? There will be something given per unit cost. All understood, na?
Yes, sir.
Per unit cost, right? So let I'm saying in a house, 20 bulbs are there, right? 20 bulbs, each 100 watt, running 6 hours every day. That means per day में कितना energy consume होता है? ना sir, 20 into 100 bulb का 100 into 6. So how much you got? 2000, 12,000 watt hour you got, na, students?
Yes, sir.
And you can convert this 12,000 watt hour into kilowatt hour, na, students?
Yes, sir.
That is 12 kilowatt hour, na, by dividing 1000. That means 12 units, right?
Yes, sir.
So you have already done those type of questions. I'm not going to that. You will get those questions in the NCERT book, right? So you calculate the total wattage, multiply the total hour. You see how much watt hour you are getting. Then if per month is in a day, you find, then you multiply this much units with number of days in the month, right? Number of days in the month. Getting the students?
Yes, sir.
Then by multiplying that and by you divide by 1000, you will get something kilowatt hour, right? Then how much total kilowatt hour you are getting? For rupees, if what you will do, how much kilowatt hour you got into rupees, right? Rupees per unit. Getting the students?
Yes, sir.
In this way, it is very easy method. You can calculate the electric bill, bill, right?
Yes, sir.
At last, let's see. This is electric current and circuit, right? These things you have to see. Go through these examples, how the circuit is connected, right? Electric potential and difference. We have learned this and these things. Go through this formula V is equal to W by Q. How that is used, what is the definition? Then this example, right? Then these three questions you do mandatory in the copy. Remember all the circuit elements, Ohm's law, experimental verification from the graph, how to determine, how to find the slope, right? And this is Ohm's law expression and question on that, how to define resistance. Then see this activity, go through everything. In between the lines also you read the NCERT. Any doubt you ask me. Factors on which resistance depend. We have learnt about specific resistance, right? R proportional to L, L by A, rho is specific resistivity, right? Reciprocal of resistivity is conductivity. ठीक. Then ये सारे examples NCERT के, कुछ भी एक line भी नहीं छूटना, जिसमें जो doubt है पूछना. ये सारे examples कर लेना. 4, 12.5, ठीक है, 12.6 सारे examples करना. और ये भी देन ये तो रेजिस्टेंस ऑफ ए सिस्टम ऑफ रेजिस्टर्स सीरीज पैरेलल के बारे में हम पढ़ चुके हैं, राइट? है ना? कैसे सीरीज में कैसे पैरेलल पे क्वेश्चन भी मैंने बता दिया, टेक्निक भी. ये सारे एग्जांपल्स क्वेश्चंस तो दिया हुआ है यहाँ पर. एक्टिविटी बेस्ड क्वेश्चन भी है, ठीक है? पूरा चैप्टर यहाँ पर भी देखो, ये सारे कर लेना है आपको. हीटिंग इफेक्टिव इलेक्ट्रिक करंट H इज इक्वल टू I स्क्वायर R इंटू टी, राइट? जो हमने एनर्जी देखे, एनर्जी इज इक्वल टू पावर इंटू टाइम ना स्टूडेंट्स, एंड पावर इज इक्वल टू V स्क्वायर बाय R इंटू टाइम. यस और नो? And that can also be
Yes, sir.
R into T, and that I square R into T is heat, correct? This is heating effect of electric current. You see here, V is equal to W. Just now we read this, P is equal to V into Q by T, that is VI, and H is equal to VIT, right? And heat developed, H is equal to I square R into T. Then questions on this, examples 12.10, just go through that, right? 12.11, then ये जो NCERT के questions है. और अभी ये practical application of heating effect of electric current कहाँ पर use होता है, कैसे. देन इलेक्ट्रिक पावर के बारे में हमने अभी पढ़े आज की क्लास पे, ठीक है? और मैंने ये 1 किलोवाट आवर स्टूडेंट देखो, 1001 into this. पावर इज इक्वल टू स्टूडेंट वर्क बाय टाइम. पावर का यूनिट होता है वाट, वर्क का यूनिट होता है जूल, टाइम का यूनिट होता है सेकेंड. दैट मीन्स 1 जूल इज इक्वल टू 1 watt second. 1 watt second. Getting students? So here you
Yes.
can see the conversion. Like here you can see the conversion, correct? Then these examples, VI, then these formulas, then everything of the NCERT you see here, all the questions, right? Here there is a question on bill consumption also. You can go through that also, right? ठीक है?
Yes, sir.
Compare paused in two resistor, each connected in two resistors from parallel with resistance, ठीक है? ये सारे आपको करना होगा NCERT के with example, right?